Greetings, everyone. Today we're going to look at adding and subtracting rational expressions, making common denominators. So we started adding and subtracting yesterday, but now we're going to have the issue of denominators that are not the same. You'll definitely want to take a few notes of these examples to help you in class. We're going to explore how to simplify our rational expressions accurately. Let's start off with something you're very familiar with. In this fraction, I want to add but have unlike denominators. So I need to multiply this whole fraction by 2 on top and bottom in order to get that like denominator. So I now have 2/10. If I check my work, 2/10 is the same as 1/5. So I know I'm right. Bring down my 7/10. Now we have our like denominators like the lesson before. We bring over our like denominator, add our numerators, and then simplify if possible. My recommendation is when you're working on assignments or notes, do a simple example like this in the corner of your paper, as it'll help you remember the rules once we add expressions. Remember, in order to add or subtract rational expressions with unlike denominators, we must first find the least common denominator. We make those common denominators by multiplying, not adding. Just like in that previous slide, I multiplied the fraction by 2 to get a like denominator. So we're going to multiply. As always, we're going to keep factoring every day. Let's take a look at this first example. The first step that you want to do is to factor. Break everything down as far as you can to make it easy to see. So my numerator, can't take anything out, there's no GCF. My denominator does have difference of squares. My next numerator is simplified, and my denominator is simplified. Now if I take a look at my denominators, my next step is to find my LCD. I want to see what is missing. We've got an x minus 2 and x minus 2. So I'm missing on the second fraction an x plus 2. So I'm going to multiply top and bottom by x plus 2. So let's take a look. That first fraction is going to stay the same. It has everything we need and it's simplified. The next fraction, I'm going to multiply each numerator and denominator. I'm going to distribute that 3 right away and then just leave the denominator factored out. I now have my like denominator. So I'm going to add or subtract. So in my numerator, I have 4x plus 1 plus 3x plus 6. Since it's addition, we don't have to distribute any negatives. All over my common denominator that I just bring over and put under everything. Step 4, let's simplify. If I look at my numerator, I have like terms. I have a 4x and a 3x, which gives me a 7x. I have 1 plus 6, which gives me 7. I'm going to bring down my common denominator. Now, I want to take a look at that numerator. I could take a 7 out. So let's do that and see what happens. If I take out a GCF of 7, then I end up with this. Now, nothing cancels. That's what I wanted to check. Sometimes pieces of our expressions will cancel because anything divided by itself is 1. But in this case, it doesn't. So I have simplified as far as I can go. So my final solution is 7x plus 1, x plus 2, and x minus 2. If you choose to leave it as 7x plus 7, I'm okay with that as well, as long as you recognize that it doesn't simplify down. Let's take a look at this example, and we'll follow our steps. Step 1, we want to factor. My numerator is good to go. My first denominator is good to go. My next numerator doesn't have a GCF, but my next denominator does need a little bit of work. 3 terms, so let's do AC method off to the side. 2 factors that multiply to get 25 but add to get 10 are going to be 5 and 5. I now have x squared plus 5x plus 5x plus 25. Group, take out an x, take out a 5. I actually end up with the factor of x plus 5 times itself, and that's okay. That is my new denominator since it is factored out. Step 2, we want to find that LCD. If I look at my denominators, this one has 2x plus 5s and this one has 1, which means this first one needs another x plus 5, so multiply the numerator and denominator by x plus 5. If I take care of that, I'm going to distribute the 4 times x, 4 times 5. On the bottom, I'm going to leave them as factors. Bring down my other fraction. I now have my like denominators. Step 3, add or subtract. In this case, be very careful. You're subtracting the 6x and subtracting the negative 1. So watch your signs. I end up with 4x plus 20, subtract 6x, subtract negative 1, which changes to adding. Bring down that common denominator. If I simplify my numerator, actually, let's say that's our step 4. We're going to simplify. 4x minus 2x is negative 2x. 20 plus 1, 21. All over my common denominator. If I look at that numerator, I want to see if there's a GCF, but in this case there isn't. So that's actually as far as I can go for simplifying this expression. So my final answer, if I clearly box it or write it out, is negative 2x plus 21 all over x plus 5, or if you wanted to write x plus 5 squared, you could do that as well because I have 2 of them. So it's up to you. Let's take a look at this next example. The first thing I want to do is to factor. And if I look, this one's already factored out, so I don't need to. If it's already simplified as far as it'll go, you're set. Step 2, find that LCD. If I take a look at what each fraction is missing, my first denominator is x plus 4. My second denominator is x minus 3. They're each missing one of them. So I'm going to take my first fraction and multiply it by x minus 3 and x minus 3. What you do to the top, you do to the bottom. And I'm going to take my second fraction and multiply it by x plus 4. If I multiply this out, I end up with a 3x minus 9 all over x minus 3, x plus 4. Keep that denominator factored out. My next fraction ends up being 8x plus 32 all over x minus 3, x plus 4. I now have my common denominator. So step 3, I'm going to add or subtract. In this case, I'm adding, so let's add the numerators straight across. 3x minus 9 plus 8x plus 32. Because I'm adding, I don't have to worry too much about my signs. Let's simplify. In the numerator, I have 3x plus 8x. So I end up with 11x. And I have negative 9 plus 32, which ends up giving me 23. Okay, be very careful with those negatives and when you're subtracting. Those are the quick little errors that can lose us a point or two. The denominator is already simplified. So let's take care of that. I want to take a look at that numerator and see if it has a GCF. In this case, 11 and 23 don't have a common factor. So that ends up being my final solution. I end up with 11x plus 23 over x minus 3, x plus 4. Let's take a look at one more example. You'll notice in this example we have 3 fractions that we are working with. We're going to follow the same steps. That first step is to factor. If I take my first denominator, I can take a GCF out. My second denominator is difference of squares. My third denominator has a GCF of x. My second step is to find my LCD. So if I take a look, I'm going to write each piece of the denominators once. So I have a 3, I have an x plus 3, x plus 3 again, but I only need to write it once. Then I have an x minus 3, I have an x, and I have x minus 3 again, but I'm only going to write it once. So what I'm looking for is what do all the denominators have in common? I'm going to rearrange this just a little bit and put that 3x out front to make it a little easier. To use that LCD, I want to multiply each numerator by the piece of the LCD that it's missing. If I start with my first numerator, it has a 3, it has an x plus 3, which means it is missing an x and an x minus 3. So I'm going to multiply top and bottom by x and x minus 3. Let's try that again. In the second fraction, I have an x plus 3 and an x minus 3. If I take a look at what it's missing, it has an x plus 3 and an x minus 3, therefore it is missing a 3 and an x. Let's try it one more time. If we look at that last fraction, I have an x and an x minus 3. which means if I have an x minus 3 and an x, I'm missing the 3 and the x plus 3. And if you notice, I forgot to multiply by my numerators. So I also have to multiply this numerator by 3x. And I also have to multiply this numerator by 3 and x plus 3. Notice the patterns I see here. That's the part of the LCD that fraction was missing. This is the part of the LCD the original fraction was missing. And this is the part of the LCD that first fraction was missing. So make sure that you cover all of the LCD in each one. Let's go through and simplify the numerator by multiplying each factor. So I have an x squared and an x minus 3. I have a plus, I'm just going to say 3x. I don't have to worry about the 1. And then I have a 12 and an x plus 3. I've got my LCD. Let's simplify it a little bit more. X cubed, if I distribute that, 3x squared, 3x, 12x, and a 36. All over that LCD. I'm going to write it out this time. 3x, x plus 3, x minus 3. The last step here that I'm going to take is combining like terms in that numerator. So we are really taking care of step 3, that's simplify. I have a cube. I have a negative 3x squared. I've got 3x plus 12x. So I end up with 15x and a positive 36. All over that LCD. Now if I take a look, there are 4 terms in that numerator. If you can, try factoring to see if anything will divide out to 1. But in this case, if I try grouping, it doesn't work. So if I can't factor or simplify or reduce any more, that is my final solution. Again, this one's a little bit tougher. Make sure you write out each piece of the LCD once and multiply the top and bottom by each piece that fraction is missing. Take your time simplifying. It's easy to make quick mistakes. Just try to stay as organized as possible and let me know if you'd like to take a look at another example.